good. I want to do just a few more examples with you of some of the trickier ones. So I had mentioned that we don't use that theta equals the inverse tangent of y over x often. So I want to show you a case where it does actually come into play. Right here on number 8, we see theta. It's very rare that we see theta by itself, not inside of a sine, a cosine, a secant, a tangent. So this is where we're going to use it. Let's go ahead and rewrite that. Theta equals the inverse tangent of y over x. Sweet. We automatically have switched this into rectangular form. Rectangular form just means get it in terms of y and x. Bam, we're done. Well, no, not really. This is not an equation you or I know how to graph. This is not an equation that looks very nice, is very simple, and I'm telling you there is something so much simpler wrapped up in there. So let's find it. Well, I have an inverse tangent right here. How do we get rid of an inverse tangent? Well, that's by doing its inverse function. And the inverse of an inverse tangent is just plain old tangent. So let's take the tangent of both sides. So the left side just simplifies to y over x. Why? Because the tangent of the inverse tangent, those undo each other, the same way a square and a square root undoes. One undoes the other. These two undo each other or reverse each other's operations, leaving us just y over x. Well, and then we get to ask the question, what is the tangent of pi over 3? Again, what is the tangent of pi over 3? Well, that's just radical 3. Oh my gosh, this is already looking so much simpler. This is looking so much simpler. Let's get x out of that denominator, isolating the y, so let's multiply both sides by x, and we get y equals radical 3 times x. I love this. Radical 3 is just a number, guys. It's not a rational number, but it's just a number. So this is just a linear equation with a slope of radical 3. There we go. We did it. So I'm not going to do number 10 with you, but I do have a little hint to get you guys going. I think you're going to have to use r squared equals x squared plus y squared along with r sine theta and r cosine theta. This one here being equal to y and this one here being equal to x. Well, if you notice, we're missing an r on both sides of the equation. We need to make this an r squared, and we need to put a factor of r in this term and that term. So, can we put an r on both sides and then use those relationships? That's my hint to you guys. Come to office hours if you want to see how to do that one. It works out quite nicely. But let's go to the hardest ones. So these are on a separate page. There are only 3 of them because these are putting everything together. They are the trickiest of the trickiest. And there is an example problem here that just shows you one of the best methods to use. And that's substitute x with r cosine, substitute y with r sine theta, and isolate that r. And isolating the r is what becomes really, really, really tricky. So I'm going to let you guys try number 11 on your own because it follows that same model. So this follows the same model. Plug in r cosine theta for x, plug in r sine theta for y, and isolate the r. But number 12 and number 13 are a little bit tricky, so I kind of just want to get you a head start on these two. Just kind of get your foot in the door so you can finish them off. So what I noticed with 12 is that I don't have the same variable. I don't have all r's, I don't have all x's, I don't have all y's, so I'm going to have some combination of something going on here. So here's what I propose. I want you guys to think about this r squared equals x squared plus y squared, and I want you to rearrange it. I want you to rearrange it to say y squared equals r squared minus x squared. Because now we can substitute that in. And I know you're thinking, I would never go this route. But these are puzzles. These are puzzles. You try things and you find out what works and you remember that method to try it again. Whoops. So now I see something kind of cool actually. This looks like pretty close to a perfect square trinomial. Let's write it differently. Yep, that is a perfect square trinomial. That is something I know how to factor. I know how to write as just x plus or minus something quantity squared. Keep going, guys. Keep going. Keep going. Come see me in office hours if you want to see how this one ends. 13. R squared equals x squared plus y squared. Cool. So all this right here is just r squared. Keep going. You can substitute that y. And now my job is to isolate the r. My job is to isolate the r. But you know that thing we're never allowed to do? We're never allowed to divide by the variable. You're allowed to divide by a variable here. If you know what I mean, you're allowed to divide by a variable. So if you want to see how this one plays out, this one actually is much simpler than the one above. It's much simpler than the one I just showed you. This one works out to be the simplest one on the page. So don't overcomplicate it. Give it a shot and come see me in office hours if you want to see how this plays out. I would love to see your solutions. As I mentioned in the last video, there's not just one way to go about these. There's not just one way to get to the answer. So if you think of something creative and you want to share it, post it to the stream in Google Classroom, come to office hours, share it with me, share it with your classmates. These are puzzles, guys, and I hope you have some fun kind of messing around with them and finding solutions to them. This is some of my favorite stuff to teach and my favorite stuff to do. So come see me in office hours on Wednesday at 9 a.m. and Friday at 8 a.m. Bye, guys.